Part 164, again we're continuing this line here of line 18A 3Z3C. It starts with line 18 3Z3A and it goes all the way up to 3D. So we have NSTX Collisionality Tokamak Plasma B Rotation Nuclear Fusion 5G Wow Seti. If you're looking into the UFO engine and you're interested in finding out all the components that go with the plasma that we're going to have to accelerate, you're going to have to backtrack. A lot of the formulas are starting in line 17 and line 18. There's tons of videos about it. We're on number 164. Okay, just so you know, if you are going to participate in this project, you'll have to look at all the videos and look at every single formula that comes up. I will be compiling all the formulas onto a website for you at the end of the series. It's going to take me a while to do it though. This is taking forever. I started this in December 2011. So here's the alien radio signal from the Wow Seti thing. That's what I googled, that number, and then all this data comes up with it, of course. So we've googled the NSTX plasma rotation. We're still this is actually directly related to the last video I just shot 2 seconds ago. This one here, line 18A 3Z3B. You want to take a look at that one, okay? Okay, so we've got a PDF file come up here for you. It's called Nuclear Fusion by M. Ono. Exploration of spherical torus physics in the NSTX device. And of course there's all the scientists that are participating in this particular test result that they've written about. It says the National Spherical Torus Experiment NSTX is being built at Princeton Plasma Physics Laboratory to test the fusion physics principles for the spherical torus concepts at the MA level. It gives the parameters, which I'm not going to read. It talks about the pulse length up to 5s, the plasma heating current drive tools. It talks about a fast wave. They use a neutral beam injection and coaxial helicity injection. There's theoretical calculations predict that the NSTX should provide exciting possibilities for exploring a number of important new physics regimes, including very high B plasma B, naturally high plasma elongation, high bootstrap current fraction, absolute magnetic well, and high pressure driven sheared flow. In addition, the NSTX program plans to explore fully non-inductive plasma startup as well as a dispersive scrape-off layer for heat and particle flux handling. And then I have a PPL image for plasma, just so you can see what it looks like. It's pretty cool looking. They make a nice screensaver. This close-up of a plasma shows the hot gas of charged particles, and it's photos by L. Starkman. Nice photo. Cool. Okay, let's go over here. Again, the NSTX is going to be studying tokamaks, spherical tokamaks, plasma heating by particle beams, which is something I haven't looked that one up yet, but that's something we're going to need for the UFO engine. We're going to need to heat up the plasma and the particle beams with that. And I got a particle gun for you to use with it. Okay? It's another invention that someone has posted. So March 8, 2012, 4:48 a.m. My thoughts: exploration of spherical torus physics in the NSTX device listed under plasma physics, issue 3Y, March 2000. The key words listed are very high plasma B, naturally high plasma elongation, high bootstrap current fraction, absolute magnetic well, high pressure driven sheared flow. So I'm going to Google very high plasma B NSTX because of course I'm not sure what it is. So and here's a learning experience for you. And here's some two fine gentlemen here. And check out the machinery behind them. That's what this thing is, this NSTX thing. Massive. Okay, so this is John Menard left and Masa Ono at the NSTX. L. Starkman is the PPPL. And these are the two that are... their names also come up in the PDF file. Interesting. Okay. So this is talking about the upgrade of PPL's National Spherical Torus Experiment Plan for 2014 operation. So they're currently upgrading it in 2012. So the National Spherical Torus Experiment accomplishments during its 11-year run and its prospects for the future. NSTX managers John Menard and Masa Ono wax enthusiastically about details. It's no wonder NSTX has been one of PPPL's most successful magnetic confinement devices, so successful that an upgraded version of the device, NSTXU, is now in the planning stage. Oh, I have to look that one up. Sorry, I didn't get a picture of it. The mission of the NSTX has been to demonstrate the effectiveness and greater efficiency of the spherical torus ST plasma geometry compared to conventional donut-shaped tokamaks. The smaller ST plasma resembles a cored apple, a sphere with a narrow hole through its middle. Its compactness and its ability to confine higher pressure plasmas with lower than usual magnetic field strengths makes the ST a strong contender as a practical fusion power. So they're looking at making nuclear fusion with it. One of the NSTX's most notable accomplishments is the demonstration of a world record toroidal beta value approaching 40% in million ampere MA class ST plasmas, which is higher by a factor of 3 than the best values achieved in conventional tokamaks. Beta is the ratio of the average plasma pressure to the pressure of the main applied magnetic field. The high beta property of NSTX mainly enabled by its small aspect ratio 1.5 compared to the conventional tokamaks 3 point whatever. Fusion power production is roughly proportional to the square of the plasma pressure, and the cost of a fusion power plant will rise with the size and strength of the magnetic field coils. Consequently, the favorable experience on NSTX could lead to more economical and more compact fusion reactors. Research on the machine has led to the advancement of methods for non-inductive startup of the plasma current and methods for sustaining this current, including neutral beam current drive and the self-generated bootstrap current. NSTX has also exhibited the efficacy of radio frequency waves for plasma heating, and within the last few years the device confirmed the existence of a long theorized form of electron scale turbulence. So that's another theory there, see? Electron scale turbulence. With the latter knowledge, physicists can now work to eliminate tiny electron scale eddies, circular turbulence about a few millimeters in diameter. In the last few years, NSTX began testing the use of solid lithium coatings on plasma-facing components to suppress the return of the colder particles escaping the plasma. Isn't that interesting? In the alien messages, it talks about lithium being used with plasma. That's cool. And it's got some other things, lithium-7 and magnesium-238. So you guys might want to take a look at those formulas. Maybe you can use them for your nuclear reactor thingy. So solid lithium coatings on plasma-facing components to suppress the return of colder particles escaping the plasma, thereby improving the plasma confinement and preventing instabilities called edge localized modes, ELMs. Now if you remember, ELMs has come up several times in the data, and I didn't really understand what it meant, but just kind of, it's got something to do with plasma. So during the current run, NSTX researchers will begin to employ liquid lithium as a means of refreshing the plasma facing surfaces with new layers of lithium to provide more continuous pumping. I wonder if they can put liquid lithium and liquid argon gas together. What would happen if you did that? So we have there we go, liquid lithium. And let's add some liquid argon gas to it and see what we get. I'm going to write it down. I probably won't remember it, but anyways, you guys stick it in the comments there if you want. ST Fusion Nuclear Science Facility. Okay. All of these accomplishments have provided strong motivation to upgrade NSTX, bringing its performance closer to that of a fusion power reactor. That's what it looks like. Enabling access to new physics regimes of higher temperature, reduced collisionality, and high beta, and preparing for our next step in fusion development based on the ST, known as ST Fusion Nuclear Facility. So we need higher beta, right? You need a reduction in collisions. Okay. The NSTX upgrading NSTX expected to take it's 5 to 12 and I'm yawning at night. a.m. No when I'm sleepy. So upgrading NSTX is expected to take about 2 years to complete. The machine will discontinue operation following its 2012 run, so it's going to stop this year, and then it's going to be off for 2 years while they renovate it, so to say. And they hope to have it up and running again by the end of 2014. So maybe by 2014 I'll have this Wow Seti data ready for them so they can take a look at it and maybe they can use it. Just a nice thought. I'm being sarcastic here. I should get it done before that. But you never know, right? It's taking forever to get this much. So this is talking about the new NRPF coils, outer coils. Isn't that cute? I like your diagrams. Nice. Looks like a little spaceship, doesn't it? Outline of the new NSTX center stack. That's what it looks like. Key paragraph quotes. The introduction of a second neutral beam injector with the same power as the first, essentially doubling the plasma heating power. There's some weird sounds going off outside my window. I don't know if it's raccoons fighting or what. It's weird. Sounds freaky anyway. The introduction of a second neutral beam injector with the same power as the first, essentially doubling the plasma heating power. The second beam will be aimed more tangentially to the plasma, so it will be more optimal for current drive. The existing more perpendicular beam, which is more readily absorbed by the plasma for a wide range of plasma sizes, is useful for heating and plasma diagnostics. Calculations indicate that the new beam will be able to drive approximately twice as much current per unit power as the existing beam. Physicists envision starting up a plasma with CHI, heating it with the radio frequency waves, and then using the new beam to ramp up the plasma current. Oh, they want to use radio frequency waves. Well, that invention that came up does use radio frequency waves, so maybe they can take a look at that. In this scenario, the radio frequency and neutral beam heating causes an increase in plasma pressure, allowing the bootstrap current to form and contribute to the final operating current. I'm going to have to look that up for you guys. You need the radio frequency waves. Yeah, I'm pretty sure we had an invention come up for you that you can use for your thing. So, new fusion nuclear science facility or component test facility. An attractive vision of an NSF is a copper magnet, deuterium tritium facility that is compact, no central solenoid. Just so you know, the Wow Seti data brought up copper, magnet, deuterium, tritium. All these words are all in the data. All of them. So it's more maintainable and runs with a very long pulse for high neutron wall loading to develop and qualify fusion reactor components like blankets. Again, lead or lithium blankets come up from a place in China. Something that they've created. They're using those for their testing for nuclear stuff as well. So maybe you want to take a look at their stuff. Such development is ultimately necessary to make electricity and breed the fuel needed for the reactor. Deuterium, tritium. Such development is ultimately necessary to make electricity. Okay, so I read that also. FNSF would operate with 8 to 10 MA of plasma current. Sorry, I'm just writing notes as I go along here. Intermediate scale STs are also being considered and might operate at 3 or 4 MA, emphasizing research on plasma material interactions, PMI, high plasma performance. Along these lines, the NSTX upgrade is also expected to make substantial contributions to PMI research due to its higher heating power, longer pulses, and leading research on lithium-based PMI solutions. So NSTXU is buying the next factor of 2 current and field to reach the parameters needed for next steps based on the ST, while also enhancing fusion plasma physics and technology more broadly, he added. ITER, an international fusion experiment under construction in the south of France, aims to demonstrate that fusion is an energy source of the future. Collisionality is a measure of how often plasma particles collide with one another as they move along the magnetic field lines of the Tokamak plasma. Collisionality decreases as plasma temperature increases. In the ST, the plasma confinement can depend strongly on collisionality. In contrast, most Tokamak data and projections for ITER indicate a weaker dependence on collisionality. The reasons for this difference are not well understood. An important goal of NSTX upgrade is to access reduced collisionality and to study how this influences plasma confinement. Again, their website's www.pppl.gov. March 8, 2012, 8:31 p.m. My thoughts. This is basically all the data I found out about the NSTX and how it's going to be upgraded in 2012. NSTX is a keyword that has come up in several lines of data so far. In the Wow Seti, search for NSTX in lines of data for line 18A3Z3C, NSTX Collisionality Tokamak Plasma B Rotation Nuclear Fusion 5G Wow Seti. I search NSTX in data results. Line 18A3Z3B VHE Y-ray Signal Crab Pulsar Velocity Nuclear Fusion NSTX 5G Wow Seti. Talks about nuclear fusion and NSTX high B plasmas. VHE Y-ray Signal Crab Pulsar and Velocity. In line 18A3Z2A5 NSTX Lithium PFC Coatings Density Graphite Plasma HEF 5G Wow Seti. Oh, there we go. Okay, you guys are going to want to use this. I just realized that. The effect of lithium PFC coatings on NSTX density control. Graphite plasma. March 8, 2012, 8:47 p.m. My thoughts continued. Creating a formula with keywords found in line 18A3Z3C. NSTX Collisionality Tokamak Plasma B Rotation. Nuclear Fusion 5G Wow Seti. You want to take nuclear fusion at NSTX, the high B plasmas, the VHE Y-ray Signal Crab Pulsar, plus velocity, plus lithium PFC coatings, plus NSTX density control, plus graphite plasma, plus ohmic helium. Added to this graphite plasma formula found in Wow Seti data on line 18A3Z2A Accelerator Graphite Plasma Deuterium Isotope Recycling UFO 5G Wow Seti has a formula. It says take lithium 7 plus the gamma ray 2.7 MeV followed by a beta decay to form plus magnesium 24 plus liquid argon gas plus electron neutrinos plus protons plus atoms plus split lepton formula equals the 5G force. Adding notes of other components from line 18A3Z2A. We have deuterium NBI reference discharges. We get this combined formula idea putting all this stuff together. We're going to have lithium 7 plus the gamma ray 2.7 MeV followed by a beta decay to form and plus magnesium 24 plus liquid argon gas plus electron neutrinos plus protons, plus atoms, plus split lepton formula, plus the deuterium NBI reference discharges, plus nuclear fusion, plus NSTX, plus high B plasmas, plus the VHE Y-ray signal crab pulsar, plus velocity, plus lithium PFC coatings, plus the NSTX density control, plus graphite plasma, plus ohmic helium equals the 5G UFO engine speed formula. The question is, who can test such a formula, and if not, using a new theories and equations, find a way to make all this work together. So here's all the videos. It's going to continue on. I'm down to my last cell of battery power, and I also have to do more research. So I'll be uploading these videos, and then I'll do some more research and put some more up there for you. Thank you for watching.